Hello everyone, as you know we are dealing with preparation methods of phenol. The first preparation method was Dow's process. From chlorobenzene we have prepared phenol. Now it's the time to understand second preparation method. We can prepare phenol with benzene and propene also. In this video we will understand mechanism also. Mechanism is not involved in 12th class syllabus. It will be for JEE, NEET and B.Sc. For 12th class only students have to learn that reaction. What that reaction is, let's check. This reaction have 3 steps. In 3 steps, this process is getting completed. The very first step I am going to write. Benzene reacts with propene. This is propene in the presence of sulfuric acid or phosphoric acid. And heating is required. 523 Kelvin temperature. We will heat it. These acids are working as a catalyst here. In this first step, the very first compound will generate this one. Cumene it is known as. A colorless liquid, cumene. Now in second step, this cumene from this cumene, we will pass air or directly oxygen gas. In air, oxygen gas is available which will react with this cumene. We call it aerial oxidation. Obviously, we need to heat it also up to 368 Kelvin temperature. Means what we are doing, suppose this is liquid cumene, we are passing directly air or oxygen at this temperature. We call it bubbling of air or oxygen from cumene, due to which in air oxygen or direct oxygen will react with this compound and we will get our second compound of this process. This CH3 will remain unaffected. This carbon will be attacked by oxygen, central carbon. 2 oxygens will join it like this. This compound is known as cumene hydroperoxide. Cumene hydroperoxide. Peroxide means this functional group. 2 oxygens with a single bond and this side another group, this side another group. Peroxide. Now in third step, this cumene hydroperoxide which is generated over here, in this cumene hydroperoxide, we will add dilute sulfuric acid, means its acidification we will do and we will heat it to 323 Kelvin temperature. After this heat, finally we will get phenol and same amount of acetone will generate. This part will become acetone, this part. And this OH will be joined with benzene ring. Not this exactly this OH. If I will tell you the mechanism, it's just a trick little bit I am telling you. Acetone and IUPAC naming will be propane 2-one. The mixture of phenol, this is phenol, the mixture of phenol and acetone can be separated by a fractional distillation method. So then we will get finally phenol. This is the work of 12th class. Or in simple language, if I will say, you have to cram these reactions in this fashion up to 12th class. And cramming is very, very difficult in organic chemistry. So we should always look for the mechanism part. Whether it is in your syllabus or not, try to understand the reactions of organic chemistry. It will improve your understanding and curiosity and interest in organic chemistry. Otherwise, organic chemistry will become very, very hard subject for you. This process for 12th class. Now let's go for the mechanism. Every step I will open with a separate mechanism. Mechanism of first step. What was the first step? In which benzene ring was reacting with propene in the presence of sulfuric acid as a catalyst. Phosphoric acid you can also use, which was creating cumene. CH3, CH3, central carbon is connected with benzene. Let's understand its mechanism. First of all, the role of sulfuric acid. As you know, sulfuric acid or any other acid will provide H positive particles. If I balance it, 2H positive and SO4 minus 2. These H positive particles have a vacant orbital, means they can work like an electrophile. They need electrons. Who can provide electrons? Two particles are there which can provide electrons to it. Benzene ring and this propene. Pi electrons are available. If it is attacking on benzene ring, suppose H positive is attacking on benzene ring, here we have H, here we have H, this one. So suppose it is attacking on a benzene ring, and any carbon, pi electrons will shift. Obviously for pi electron, it have to attack on carbon. Carbons will provide pi electrons. Na? It have a vacant orbital. For the bond formation, 2 electrons are required. This carbon will provide electrons in the form of pi. It will break bond from the neighbor carbon and will shift here for the bond formation of with H. Vacant orbital, pair of electron will make bond, dative bond. Due to this, this carbon, which is losing its electron, will have a vacant orbital and will turns to +1 charged particle, carbocation, and here the 2 hydrogens will generate. Okay. Means benzene ring has lost its aromatic character. Benzene ring is aromatic because it contains 4n plus 2 pi electrons. 11th class Huckel rule. N value if you will put 1, you will find 6 pi electrons must be there to make a compound aromatic. It has 6 pi electrons. But here it have only 4 pi electron. 4 pi electron is not a condition of aromatic compound. Means benzene ring has lost its aromatic nature. To bring its aromatic nature again, what it will do? This carbon has made this carbon unstable. So this carbon will rearrange its stability. How? By breaking bond from old hydrogen and will shift it here. And obviously electrons will completely shift toward carbon because hydrogen is less electronegative. Double bond will generate. So you can check. Again, the H positive is released out. H positive is looking for the electron. If it will attack on a benzene ring, it will happen. Second option, it can attack on carbocations. It can attack on propene, this one. For pi electrons, it have to attack either this carbon or this carbon. It will attack on this carbon. Reason? When pi electrons will be shifted and these electrons will be used for the bond formation of hydrogen with hydrogen, this carbon will become carbocation because it has lost its electron. And here, between this carbon and this hydrogen, dative bond will generate. Due to this, because this electron is completely transferred toward hydrogen, so its positive charge will finish like this. This electron is completely transferred toward hydrogen. 2 degree carbocation is generated. It will not attack on this carbon because if it will attack on this carbon, pi electrons will shift to that side. 1 degree carbocation will generate. Please try by yourself. Already we have done these concepts. 1 degree carbocation is less stable as compared to 2 degree carbocation. So this hydrogen is preferring to attack on this carbon for electron. Which rule it is? Markovnikov rule. Now, benzene ring is as it is. Here 2 degree carbocation is generated. In this 2 degree carbocation, you can check carbon have a vacant orbital. Wants electron itself, it is an electrophile. Means one electrophile has created another electrophile. It is 2 degree carbocation looking for the electron. Who can provide electron? Benzene ring. Which was also attacked by H positive. Yes, H positive is attacking on benzene ring also. Mechanism will say, if you will check book, you will find out H positive is attacking on a propene. Why not benzene? Why book is not writing benzene is attacked by H positive? Benzene ring is also attacked by H positive because H positive is looking for electron. Benzene ring also have electron. But the problem is that is not visible to us. If it will attack, again, benzene ring will generate, H positive will release out. Means H is replacing H. What does it mean? So that's why these side reactions are not written in a book. Those reactions which are bringing out main reaction, they are written there. So, when 2 degree carbocation is generated, this 2 degree carbocation is looking for the electron. Now it will go for benzene ring. because benzene ring is also a source of pi electron. Any carbon it can select. Right now all carbons are symmetrical. With its vacant orbital, it will attack on any carbon. This carbon I am attacking. For bond formation, 2 electrons are required. It don't have electron, vacant orbital. So the responsibility of providing electrons will be of this carbon. What it will do? It will bring these pi electrons here for the bond formation for this carbon. Means this compound will generate. This carbon is going to make dative bond with this carbon. This one. Positive charge of this carbon will finish because it got one extra electron. This carbon, here it is. Out of these 2 electrons, 1 electron it will transfer completely toward this carbon and 1 it will keep with itself. So after passage of 1 electron completely toward this carbon will become neutral, this one. But the problem will arise for this carbon, it will become positively charged because 1 electron it has lost. This electron was of this carbon, but it has lost positive charge. Carbocation is generated. Is it stable? No, it is unstable. How it will bring its stability back? The carbon who has made it unstable will make it stable. How? We know on this carbon hydrogen is there. This one. This carbon will break bond from hydrogen and obviously electrons it will keep with itself and will shift them here. Vacant orbital, electrons will come, bond will generate between these 2 carbons. Double bond. CH, CH3 as it is, no problem. Double bond is generated again, regenerated. Please check this compound, cumene it is. A colorless cumene liquid will generate. And from here, what is released out? H positive, who has lost its electron. What this H positive will do? It will repeat whole cycle again with another molecule of propene. Same process will be repeated. So this is the mechanism of first step. This whole reaction is also known as Friedel-Crafts alkylation. Friedel-Crafts alkylation. Because alkyl group, this is alkyl group which is joined on benzene ring. So that's why this is known as Friedel-Crafts alkylation also. This was the mechanism of first step. Let's go for the second step mechanism. Now what will happen with this cumene? The second step was this cumene which we are using, we have passed air or oxygen gas and we heated it up to 368 Kelvin temperature, due to which another compound was generated, this one, cumene hydroperoxide. Cumene hydroperoxide. Let's check what is the reaction, what is the mechanism behind this reaction. Number 1, note down. It's a free radical reaction. Means it will happen with the help of free radicals. What are free radicals? Already I have told you. An atom which have one unpaired electron unused. Such atoms are known as free radicals. So during this process, free radicals will generate. Means this reaction is happening with free radical mechanism. And we know free radical mechanisms are happening in 3 steps. Chain initiation means start of the reaction. Second, chain propagation. Means progress of the reaction. In this step, products are generated. And the third step, chain termination. Means end of the reaction. All those reactions which are trying to stop the process, we used to write it in this step, chain termination. Chain initiation, chain propagation, chain termination. Let's start. Chain initiation. For chain initiation, we need chain initiator who will start the whole process, free radical process. You can call it radical initiator also. For radical initiator, in this process, we are going to use benzoyl peroxide. This is the formula. This is benzoyl peroxide. Again, you can check peroxide. It is peroxide, this one. Very less amount of benzoyl peroxide we will put in cumene, little amount. And we will heat it. What will happen? This benzoyl peroxide will start this whole chain process. How? By creating initial free radicals. How? It always break from here. Oxygen is connected with 2 electrons, sharing of electron covalent bond. So when bond will break, 1 electron with this oxygen, 1 electron with this oxygen. I am writing this part. Second part will have same phenomena. This will generate. Oxygen free radical is there. Unpair, unused electron, this one. 2 pairs are already there. I am not drawing them. Please draw by yourself. Now this unpaired electron needs stability. Is it stable? No. Unpaired electrons unused are never stable. They try to make bond, covalent bond, to make itself stable. How? For this stability, this carbon will help. It will break bond from its neighbor carbon, and 1 electron it will shift here. 1 electron from this carbon, 1 electron from oxygen. They will make CO2 gas, carbon dioxide gas. You can check oxygen is stable now. And from here, another free radical will generate on this carbon. 1 unpaired electron will left here. Phenyl free radical, phenyl carbon free radical. Now this phenyl carbon free radical will react further. To which? Cumene. It will react with cumene. This is the role of benzoyl peroxide. It will provide initial free radicals, which will bring another free radicals, or which will make another free radicals for the course of the reaction. This is phenyl carbon free radical which is generated from benzoyl peroxide. Now what this phenyl carbon free radical will do? Check. It's a chain initiation step which is going on. Please note down. Yes, here we have cumene. Now the phenyl carbon free radical which is generated, unpaired electron, making it unstable. What it want? It want one more unpaired electron for its stability. For that, it will attack on hydrogen, this hydrogen, and bond will break like this. 1 unpaired electron, they will make bond. Due to which, your cumene will turns to cumene free radical. This carbon will become free radical because 1 unpaired electron is left. Its hydrogen will go to make bond with benzene, this one. So your normal cumene will turns to cumene free radical. This was the role of benzoyl peroxide. Little bit benzoyl peroxide will make your cumene particles cumene free radical. Now further work these cumene free radicals will do by their own. The role of benzoyl peroxide is finished. Now in my mind the question is, why I have attacked only this hydrogen? Why we can't attack these hydrogens? The reason is, after attack of this hydrogen, this phenyl free radical will make another free radical which is 3 degree, if you will check it, it's 3 degree benzyl free radical. 11th class concept it is. It's a 3 degree benzyl free radical. And if I will attack these carbons, these hydrogen, 1 degree free radical will generate. If I will attack this carbon, 1 degree free radical will generate. Reaction will prefer 1 degree free radical or 3 degree free radical. Answer is 3 degree free radical because 3 degree free radicals are more stable as compared to 1 degree. 11th class concept. 3 degree carbon free radicals are more stable as compared to 1 degree. That's why this hydrogen is replaced, this one. This is the first step, chain initiation. Chain is initiated now. Now the further work will be done by this cumene free radical. Let's go for the chain propagation. chain propagation step. In this step, the main products will generate. The cumene free radical which is generated over here, when will come in the contact of an oxygen gas? You know, in this step we are passing oxygen. When free radical come in the contact of a normal particle, it will make it free radical. When it will strike to it, what will happen? This oxygen is normal, they will break like this. One electron to this oxygen, one electron to this oxygen. Means they will turns to oxygen free radicals like this. Two lone pairs I am writing here. Now this unpaired electron, unpair, they will satisfy each other by making bond and it will generate this compound. I am not writing lone pairs of oxygen, draw it by yourself. This oxygen will become stable by making bond, unpair, covalent bond. This is generated here. But this oxygen, second oxygen is still unstable. You can check. Unpaired electron we have. This one. What this will do? Look, one free radical reacted with normal molecule, making another free radical. Now this free radical will react with another molecule of cumene, because we know in this mixture cumene and oxygen gas is available. Benzoyl peroxide was there but was in very less amount, which we have utilized. That's it. Now further reaction is carried out by these particles. Cumene particle, this was cumene. Now this free radical, this is oxygen carrying unpaired electron, will again attack on this hydrogen to create this hydrogen, and this carbon bond will break like this again. Unpair will make stabilize each other. So we will get finally what? This oxygen hydrogen bond will generate unpair covalent bond. What is this? This is cumene hydroperoxide. Cumene hydroperoxide, which was the product of a second step. And what about this? It will become cumene free radical like this. What it will do? It will again react with another molecule of oxygen and the whole process will be repeated again, repeated again, repeated again. What will generate? Cumene hydroperoxide, cumene hydroperoxide, cumene hydroperoxide. This is the meaning of chain propagation. Products are generated. One free radical is finishing, another is generating, and product is also generated there. This is the second step, chain propagation. Now third step, I will not write, chain termination. Chain termination, write by yourself. What are chain termination reactions? In which two free radicals will combine, but no new free radical will generate. So such reactions are trying to stop the process. For example, once I am writing, like I have cumene free radical reacts with another cumene free radical. CH3, this. They will combine. Now, when two free radicals are generated, you can check no new free radical is generated. So, such reactions are trying to stop the process, because for chain reaction, continuous generation of free radical is important. So, please write down chain termination steps by yourself. In this fashion, cumene hydroperoxide will generate. This is the mechanism of second step in the whole process. Now, after generation of hydroperoxide, cumene hydroperoxide, let's go for the final step of the process where phenol will be generated. What was the final step? The cumene hydroperoxide which is generated, we will put dilute sulfuric acid in it and we will heat it up to certain temperature. In this step, finally we will get phenol and what? Side product, propane 2-on or acetone. Phenol and propane 2-on, these are generated. Let's check the mechanism of this, how this reaction is happening. The sulfuric acid which you are using, dilute sulfuric acid, again it will give what? H positive particles. Balance form, if you will write this one. What they need? These are electrophiles. What they need? Electrons. where we have electrons. In cumene peroxide, two oxygens are available with their lone pairs. And you know, these oxygens are very close, feeling repulsion, means their lone pairs are ready for the donation. Due to repulsion, the lone pairs are moving little bit up, due to which electrophile can easily attack on them. So what will happen? Out of these two H positive, only one H positive I will use for the completion of the mechanism. So H positive will attack on this oxygen. Not this oxygen, because this oxygen have less crowding. Around this oxygen we can check crowding is there. So this oxygen will be attacked, and dative bond will generate between this hydrogen and this oxygen. What compound will generate? Let's check. As this oxygen will make dative bond with hydrogen, only one pair will left, because in this pair two electrons were there. One it will completely transfer toward hydrogen like this, and one it will keep with itself. As it will transfer one electron toward hydrogen, the positive charge of hydrogen will finish 0, but on itself it will have a +1 charge, because it has passed one electron completely toward hydrogen. Will making it stable, what will happen? It will break bond from neighbor oxygen. H2O will release out. Because it is unstable, third bond it will break from oxygen. Because it have a positive charge, means it have a more tendency to attract electrons. So that's why it will attract electrons from its neighbor oxygen, due to which its neighbor oxygen will become positively charged oxygen with a vacant orbital, because one electron of its has gone with this oxygen, H2O, and this one. This will generate. Now what will happen with this intermediate? Let's check. This is a oxygen with a vacant orbital positive charge, wants electron. Yes, vacant orbital is there, wants electron. Who can provide electron? Yes, the high source of electron is in its neighbor, benzene ring. How? Look, this oxygen is close to this carbon. So this carbon will try to provide electrons to this oxygen. How? By breaking bond, these pi electrons. These pi electrons, it will first shift toward itself and will provide two oxygen like this. This is happening over here. Due to which the changes which will arise here, that I am going to write. The changes are these CH3 as it is. Between this carbon and this oxygen, a bond will develop. And on this carbon, positive charge will come, because it has lost, this carbon has lost its electrons. So here we have a vacant orbital and a positive charge. Oxygen positive charge will finish, because the positive charge was due to shortage of one electron. It is getting one electron, this one, completely. Here it is. Means a dative bond is there between them. So its positive charge will finish. This type of intermediate which is generated here, it is known as bicyclophenonium ion. Why we are calling it bicyclo? Two cyclic rings are there. You can check. First this one and second this one. Carbocation it is. Bicyclophenonium carbocation. Is it stable? Will it remain like this? No. It will change itself. How? Which carbon has made it unstable? This carbon has made it unstable. So this carbon will rearrange its stability. How? This carbon will break bond from its neighbor carbon, this one, like this, and will shift these electrons here like this. Due to which what will happen? We will get double bond here. Now please check connection properly. Don't get confused. This carbon is making bond with this oxygen that I am making. Between this carbon and this carbon, bond has broken, and this carbon is connected only with oxygen. So here it will be. With a vacant orbital, positive charge will be there. Yes or no? Carbocation will generate because it has lost one electron, which is transferred toward this carbon for its satisfaction. This one. Carbocation will generate. This is happening. Now what it wants? Electron. What it wants? Electron. Electrons will be given by which particle? Check. We are using dilute sulfuric acid. In dilute sulfuric acid, dilute word we know what means presence of water molecules, H2O. H2O, in H2O, oxygen have a lone pair. You will say, can't this oxygen provide lone pairs? Okay, it will provide, will make a double bond, but in that condition, this oxygen will become unstable. Positive charge will come, 3 bonds it will make. Molecule will make a stable or unstable particles. Stable particles. So that will be temporary stability. We want permanent stability. Permanent stability we can get from H2O. Lone pair of oxygen will make bond with this carbon like this. What will happen? This benzene ring as it is, no change. Oxygen as it is, no change. CH3 as it is. This oxygen will make dative bond with this carbon like this. This one. So obviously this oxygen is delivering its one electron completely toward this carbon. Here it is. So it will get +1 charge. Unstable. How it will get stability back? By breaking bond from hydrogen and getting electrons back toward itself, because oxygen is more electronegative. Means from here H positive will release out like this. What will happen? Side by side write down what changes are arising. It will be like this. H positive is released out. Now single carbon with 2 oxygens. What condition it is? Highly unstable condition. Because 2 oxygens will be very close, lone pair repulsion will be there. So obviously one oxygen will break bond. Which oxygen? This oxygen will break bond to decrease the steric hindrance, crowding problem. Obviously when it will break bond from carbon, so electrons will shift toward oxygen. At the same time, this carbon will have a vacant orbital, positive charge, which will be balanced by neighboring oxygen by breaking bond from its hydrogen like this. Please check. Unstable condition it is. Single carbon carrying 2 oxygen, already discussed with you. 2 oxygens on a single carbon are never stable. Out of these 2 oxygen, 1 oxygen will definitely eliminate out from the molecule because crowding is there, lone pair, very close they are. Same condition is here. So oxygen is going out, this oxygen. Why? Because it's a bulkier group. By the release of this bulkier group, this molecule will get high stability. Now check. Yes. Oxygen is eliminated out. And obviously when it will bring electrons toward itself, negative charge. And when this hydrogen will out from here, H positive, this H positive, this O negative, it want electron, it want to deliver electron. Both can help each other. What they will form? Quickly check. Let's complete the mechanism quickly. Very long mechanism it is. Here I am writing, so it will be visible. Phenol. What is generated? Phenol. And what about this part? You can check. Carbon was getting vacant orbital, which is satisfied by the oxygen by putting these electrons here. Means double bond will generate. Means this group will turns to, don't you think, like this? Double bond will create CH3 as it is. Carbon doubly bonded with oxygen. What it is? It is acetone. Propane 2 on. That's it. This is the mechanism of the whole process. Shiftage is important in this mechanism. One point I have done there. Please check. Please note down. It is left. In this mechanism, this oxygen was positively charged. this benzene ring was shifted completely toward oxygen like this. Making this as a carbocation. This is known as 1,2 phenyl shift. This is first, this is second. From second carbon, it is going toward first oxygen. So this is 1,2 phenyl shift, making this oxygen stable. Now one point is arising in my mind. Why we have not done methyl shift? Oxygen need electron. We can do this also, no? Like this. It is known as methyl shift. Why we have preferred phenyl shift? Because oxygen want electrons. Benzene ring is a better source of electrons because it contains pi electron as compared to CH3. That's why at the place of methyl shift, we are preferring what? Phenyl shift. Not we are, molecules are preferring phenyl shift. That's it. This is the end of the mechanism. Now in next video, we will understand next preparation method with mechanism. Thank you very much.